In this video, we're going to talk about the concept of determinant in 3D space. In the last video, we saw if we have a parallelogram with sides as vector A and vector B, then the area of parallelogram is given by an absolute value of determinant of vector A and vector B. Now let's take this concept into the three-dimensional space, where instead of vector A, B and C, we have another vector, say C, such that A, B and C vector forms a cuboid in a three-dimensional space. Okay. So let's first see how will we solve a determinant of these vectors in a 3D space. Okay, so let's consider three vectors. A vector as A1 I cap plus A2 j cap plus A3 k cap. B vector as B1 I cap plus B2 j cap plus B3 k cap, and C vector as C1 I cap plus C2 j cap plus C3 k cap. Then determinant of A, B and C is given by a determinant of A1, A2, A3, B1, B2, B3, C1, C2, C3. The way to solve this is you take A1, you ignore the column and the row which contains A1 and take a determinant of the remaining vector. So B2, B3, C2, C3. Then as a second sign, you take minus, take the value A2, ignore the row and column which contains A2 and multiply it by a determinant of the B1, B3, C1, C3, and the third term is basically A3. You ignore this and then you have C1, C2, which is then equals to A1, B2, C3 minus C2, B3 minus A2, B1, C3 minus C1, B3 plus A3 into B1, C2 minus C1. Great. So you should remember, I think you should not remember this big formula, but you should remember this formula, right? So if you have three vectors in space, then the determinant of that vector is given by A1 determinant of the remaining two minus A2, ignoring the rows and the columns which contain A2, and then taking the determinant of the remaining plus A3 and so on. Great. So what does the determinant in 3D space actually geometrically means? So if you have a parallelepiped with sides as vector A, vector B and vector C, then determinant of A, B and C is nothing but volume of parallelepiped, right? So determinant is volume of parallelepiped. Again, we don't know the sign, as it could be positive or negative depending on the values of A, B, and C and the directions of A, B, and C, and therefore the magnitude or the absolute value of this determinant is volume. A 3D figure. Great. So you know how to solve a determinant value in the three-dimensional space, and you know what it is geometrically means. However, how do we reach from here to define the concept of cross product? Let's take this. Okay. So if you have a three-dimensional space x, y, and z, you have two vector in this space, which is a vector represented by coordinates a1, a2, and e3, and b vector represented by p1, p2, and p3, then a cross product between a and b. Right? So see the notation, which is different than this, is determinant of AB in this space. Now note there is no third vector, so how would you solve this? So the way to define A cross B, so definition A cross B is, instead of A1, A2, A3, you will take a three-dimensional space and a unit vector across these three space, which is I, J, and K, and then you will put A1, A2, A3, B1, B2, B3, and therefore A cross B is, now let's solve this determinant, which is A2, A3, B2, B3, I cap minus A1, A3, B1, B3, J cap plus A1, A2, B1, B2, J hat. Right? So this is how you solve A cross B. There's another formula which can be seen if this was an angle theta, then A cross B is equals to mod of A into mod of B into sine theta. Right? So we say it is a area of parallelogram into a vector. Right? So A cross B is a vector, because that's why it's called a vector product. So it has a certain magnitude and a certain direction. Okay. So we have seen how to compute A cross B if you've been given vector A and vector B with two different formulas. So you know how to get to the magnitude of A cross B and how to represent it in a vector form. If you need to find out the direction of A cross B, how would you find that direction? Great. So let's see the direction. Okay, let's consider there's a three-dimensional space which contain these two vectors, A vector and B vector. So A cross B, we need to find a direction. What is the direction? So let's talk about a concept called a right hand. So what does that mean? If you take, so the right hand rule says that if you take a right hand and you take all of your fingers and rotate your fingers from A to B, then your thumb will point in the direction perpendicular to this plane, perpendicular to the plane, and that is what the direction is. So if you rotate it from A to B, your finger from A to B, then your thumb will point in the direction perpendicular to the plane, in this case outward from A, then that is the direction of A cross B. If you have to find B cross A, then you will have to rotate a finger from B to A, and in that direct case you will still have a perpendicular direction of n cap, but it will be in the downward direction to this plane, rather than pointing upward, it will point downward. So therefore A cross B is a vector perpendicular to plane that contains vector A and vector B. Also, A cross B is equals to minus B cross A. That is, they have the same magnitude, but one is facing upward direction to the plane, the other is facing downward direction to the plane, right? So this is a very important concept. So remember, A cross B is a vector. A cross B is a vector with magnitude as A, B sine theta and direction perpendicular to the plane given by right hand rule. Right? This is another important concept. So what is this? In the previous video, we saw that this is nothing but area of parallelogram with side as A vector and B vector. To repeat one more time, A cross B is area of parallelogram contain whose two sides are represented by vector A and vector P with direction perpendicular to plane that contains A and B, and hence A cross B is A vector, B vector, sine theta, this is an angle theta, the n cap. Other formula is A cross B is equals to IJK, determinant A1, A2, A3, B1, B2, B3. It's given by determinant of the vector A and vector B. In the next video, we'll again go back to our original problem, which was calculating a volume of 3D figure using cross